Have you ever wondered why the sum of 1/2, plus 1/4, plus 1/8, and so on, equals exactly 1? In this video, we are going to prove that to you in 3 different ways. Let's start with proof number 1, the visual proof. First, let's draw a perfect square that has an area of exactly 1 unit. Next, we divide it straight down the middle into 2 equal halves. This gives us a section that is exactly 1/2 of the total area. Now, take the remaining half and divide it in half again. This gives us a piece that is exactly 1/4. If we continue this exact process, always splitting the remaining space in half, we get sections representing 1/8, 1/16, 1/32, 1/64, and so on, stretching out to infinity. Now shade the first portion, the second portion, the third portion, and so on, respectively. You can see that they all tend to fill the entire square, which has an area of 1 unit, as we approach infinity. Hence, this gives us a solid visual proof that the sum of 1/2 plus 1/4 plus 1/8 and so on equals 1 at infinity. Now, let's move on to our second proof, the telescoping algebraic proof. Let's define Sn as the sum of our series up to the nth term. So, Sn equals 1/2, plus 1/4, plus 1/8, and so on, all the way to 1/2 to the power of n. The trick here is to rewrite every single fraction as a subtraction problem. The first term, 1/2, can be written as 1 minus 1/2. The second term, 1/4, can be written as 1/2 minus 1/4. The third term, 1/8, can be written as 1/4 minus 1/8. Following this pattern all the way to the end, our very last term can be written in general as 1/2 to the power of n minus 1, minus 1/2 to the power of n. If we substitute these pairs back into our original equation, we can rewrite our entire sum like this: Sn equals the quantity 1 minus 1/2, plus the quantity 1/2 minus 1/4, plus the quantity 1/4 minus 1/8, and so on, all the way to the quantity 1/2 to the power of n minus 1, minus 1/2 to the power of n. Now, watch closely. When we open up the parentheses, a beautiful chain reaction happens. The negative 1/2 cancels out the positive 1/2. The negative 1/4 cancels out the positive 1/4. This collapsing effect cascades all the way down the line, just like a folding telescope. Every single middle term completely vanishes. After all the dust settles, we are left with only 2 terms, the very first number, and the very last component. Sn equals 1 minus 1/2 to the power of n. To find out what happens when this series goes on forever, we take the limit as n approaches infinity. As n grows massively large, the fraction 1/2 to the power of n shrinks down to absolute 0. That leaves us with 1 minus 0, which equals exactly 1. Proof number 2, complete. Now, let's move on to what might be the most elegant and amazing proof of them all, the algebraic shift proof. This method feels almost like a magic trick because we can solve for the entire infinite sum using just the basic rules of algebra. First, let's assume that our infinite sum adds up to some total value. Let's call this total value s. We can write our equation like this: s equals 1/2, plus 1/4, plus 1/8, plus 1/16, and so on. Here is where the magic happens. Let's take this entire equation and multiply both sides by 2. On the left side, s becomes 2s. On the right side, watch what happens when we distribute the 2 across every single fraction. 2s equals 2 times the quantity, 1/2, plus 1/4, plus 1/8, plus 1/16, and so on. 2 times 1/2 equals 1. 2 times 1/4 simplifies to 1/2. 2 times 1/8 becomes 1/4, and so on down the line. Let's write out our new shifted equation: 2s equals 1, plus 1/2, plus 1/4, plus 1/8, and so on. Look incredibly closely at the tail end of our new equation. The infinite sequence of fractions, 1/2, plus 1/4, plus 1/8, and so on, is the exact same sequence we started with. And remember, we already defined that exact infinite sequence as being equal to s. Because it goes on forever, we can literally substitute the letter s right back into the equation where those fractions are. That simplifies our math down to this: 2s equals 1 plus s. Now, all we have to do is solve for s. Let's subtract 1s from both sides of the equation. 2s minus s leaves us with just a single s on the left, and we are left with 1 on the right. S equals 1. Just like that, algebra proves that our original infinite sum is exactly equal to 1. It's simple, clean, and absolutely mind-blowing. Proof number 3, complete. Whether through shapes, collapsing terms, or algebraic magic, math proves that an infinite journey can lead to a precise destination. If you loved breaking down this logic, smash that like button and subscribe to Sparkling Tutorials for more. Thank you for watching, and see you in the next video.